really recommend, if you're into music and all that, go to his website and check out the behind the scenes. Those are all science experiments you see, and they made a video of the science experiments and mixed it with some music, and that's what you got. But I believe that's what they're hiding. It is an electrical universe. Tesla was right. Edison is definitely wrong. The shirt says. Thank you.
All right. Well, I'd like to thank Bruce for being able to come down to the lion's den and face the skeptics. Pretty interesting stuff. I would like to, before I get started, just mention that I work with people that go to Antarctica, and I asked Kevin, hey, how can a citizen hook up with a trip in Antarctica? And there's Union Glacier Station, and I think I told you about it. But it's a real company, and if you've got the bucks, they will plan your trip to the South Pole.
All right,
right there, Union Glacier Station.
Okay, I understand there is groups down there working at the South Pole doing research, but how far are you allowed to go to out of the South Pole? How far can you travel without telling somebody? Can you? Yeah, well, if you're in the South Pole, I mean, do I have to let them people know? Can I just hop on my ski and do whatever I want to? Or do I have to let somebody know that I'm doing something? Is it a control? Am I controlled on there?
Yeah. So this Union Glacier Station is just a place. It's a commercial outfitter, and they have lots of canned trips, mostly around the rim of Antarctica. But that's the place to go. I mean, I talked to the insiders that know, if you want to arrange your trip walking to the South Pole, go to the Union Glacier Station. And they have a number in Salt Lake City, you can call them out.
Yeah, but I feel that's not going to give me a trip across the pole. I mean, I can go there and sit at some ice that I got there and, sit
It's the closest to what you want. So can you have a seat for a moment? I got some more questions. So yeah, science is all about asking questions. So science is all about testing explanations. So I came across this, I made this drawing, but the sun is 3,000 miles above the flat Earth, and the sun moves in different circles depending on the time of the year. So the equinox, it's over the equator. In the summer, it's over the Tropic of Cancer. Winter over the Tropic of Capricorn. Bruce, is that the...
That's the basic, understand, that's the basic theory, yes.
Okay. All right, thanks. So here's a little animation I made using that theory that we just saw. This is what the flat Earth sun should look like. And we see the flat Earth sun never sets. And it changes side as it swoops in around lunchtime. It would get much bigger, and we don't see the sun doing that. And but mainly, it never sets, never goes beyond the horizon.
Well, can I comment on that?
Sure.
That is also saying that you know what the sun is, that you know what the sun is doing and what it is. You're saying it should get bigger. Why should it get bigger? Do you know what the sun actually is?
Based on if the sun was, as Robotham and I think others explained, 40 miles across and 3,000 miles up, yes, it would change size.
If we theorize that it was this ball of thing, we don't even know what it is. They try to say what nuclear fusion it is, but it can't be proven. Matter of fact, it's the mainstream science is pretty not all over the place on actually what the sun is and what it does.
It's actually
consider that we should see it smaller.
Pretty settled. The sun is pretty settled. So here's a point I wanted to make. Why would you keep a model that has been falsified? Here is the Earth on the equinox. So September 21st, March 21st, and at that time this shows dawn right here in Albuquerque, New Mexico. And longitude 107 west, and at dawn on the equinox, the North Pole is having the shadow, the terminator, and so is the South Pole. Every point along longitude 107, and it's due east. The sun is rising due east because it's 93 million miles off. So to test this, I went to Google Maps, got a map of Socorro, and found the street, B Street, that is due east-west. And on the appointed day, September 22nd this year, in the morning, I got up early and lined up right about here. And sure enough, the sun rose directly east on that flat earth movie, based on the theory that is the sort of prevailing flat earth theory. The sun should have appeared here, which is 30 degrees west of
I've
east.
actually never heard any flat earthers positively say they know what the sun is, for one, and what it's doing, for number two. We do have an idea that it does. This is from the ancient people.
Yeah.
If you look at the Mayans, they figured out Venus' transition. They figured out everything in the heavens and wandering stars. You do all on the belief that we lived on a flat, motionless plane.
Okay.
How do they figure all that out? If we're on a spin ball, how do they figure it out?
So if you want to do science, you have to say what the sun is. And mainstream science says the sun is this ball of hydrogen and helium, 93 million miles away, and 100 times wider than the Earth.
You believe them without any actual.
But that's a theory. It's a definite theory. You're telling me that your guys don't know what the sun is? They can't say what it is? That's not a theory that can be tested.
Theories, but don't pass your theories off on as fact.
If you can't tell us what the sun is, you don't have anything that can be tested.
No, we can sit there and say we don't know. It's easy. It's okay to say you don't know.
Can I make the point about this graph? This graph is showing that in the heliocentric model, the sun is rising in the east, just like it shows here in the picture. In the flat Earth model, the sun would be over Dakar, Senegal. It would be noon over there in Africa, and that angle to the sun would be 30 degrees. The sun would be in the wrong place. So that's an experiment we can do to find out where the sun should be, and the sun is where heliocentric theory says it should be. The sun is not where flat Earth theory says it should be. So that's an experiment we can do.
Okay, cool. Is that the AE map, or is that the United Nations?
That's a polar stereographic azimuthal projection that I made myself using science and math. I have a little math program that basically that is the polar azimuthal projection. That is called the flat Earth map. Yeah, that's it. So here's an experiment I can do. If I, on the equinox, measure my shadow, the shadow of this stick, and measure the shadow and the height of the stick, I can very easily calculate my latitude. Here I'm calculating the latitude in Socorro, 34 degrees, because on the equinox, according to heliocentric theory, the sun is above the equator, and the elevation of the sun is the co-angle to the latitude. I can measure my latitude by measuring a length and a shadow at noon, and it checks out. There it is, 34 degrees. So I measured Socorro's latitude. On the solstice, like coming up in a week or so, you measure the shadow much longer in the winter, the sun's much lower, the height's the same, and now because the sun is above the Tropic of Capricorn, the sun elevation is the co-angle of the latitude plus the Earth's axial tilt. We know the latitude from the equinox, so we can calculate the Earth's axial tilt, 23.5 degrees. Anybody can do this anywhere on the Earth, in Chicago, in Kansas, in South America, in Africa, anywhere on the Earth.
Huh? What's telling you the Earth is tilting? What's telling you that Earth is tilting?
We just measured it.
Are you just assuming the Earth is tilting?
No, we measured the Earth is tilting. There's the shadows and the height of that stick, and there's the math, and there's the measurement, 23.5 degrees.
You assumed the Earth was tilting, and then you figured out.
No, I am calculating the tilt based on heliocentric theory. It's a calculation, it's not an assumption. And anybody in South Africa, in India, in Kansas, anywhere on Earth, can do this experiment for themselves, and they get the same tilt. So you can take that experiment and assume that the flat Earth theory is correct, and you can calculate the height of the flat Earth sun,
And like you just explained, like I said, you assume the Earth was tilting because you take the same math and...
here I'm assuming flat Earth theory is correct so I can test it. So in the flat Earth theory, the North Pole is about 6,000 miles from the equator and about 12,000 miles from the South Pole, which is supposedly the ice wall at the edge of everything. And it works out that the distance, according to a certain latitude, is simply 200 over that latitude in miles. So here's a formula for the height of the sun based on your latitude, and when I use that in Socorro, the sun is 3,360 miles above the flat Earth. But if you run that at different latitudes, the height of the sun is much lower. If you're at southern or northern latitudes, it's 3,000 miles, the supposed optimum at 45 degrees latitude, and it's higher, it's almost 4,000 miles when you get to near the equator. Here it is. So anybody on the Earth can measure the height of the sun. You get a different height of the sun depending on your latitude. Whereas when we were measuring our latitudes on the equinox, everybody got their correct latitude. So the heliocentric model is working, flat Earth model is not working.
Stellar parallax, assumption.
Yeah.
Assumption and more assumption.
No, this is something we measure. We can actually see.
What's the definition? Tell me the definition of stellar parallax.
The stellar paradox, it shows that this foreground star appears to move against the background stars because of the year. Let me speak, please. We gave you a turn. Let me have a sentence.
You won't let me sit there and say, what does appear mean to you? What is it? Why does it say apparent movement? Why don't it just say the movement of stars? Why don't it should just say the movement of stars? No, it's the apparent movement of stars. There's a reason why.
What this describes is we see some stars far away, and we see one star moving, and the other stars are not moving. And why is that one star moving? It's because the Earth is orbiting the sun. And because just like when I'm moving, I can see the audience move against my fingers. It's parallax. It's a scientific thing.
Can you wait 6 months later, and then where's that star back at? It's right back to where it started a year ago, wasn't it? Well, whatever.
In 6 months, it's going to be it's extremely different. In 12 months, it'll be back where it was.
Never moved. It just went in a cycle, and if you do it, if you measure it once and then wait 1 year and measure it again, guess what? That star's back in the same.
Yeah, because things do the same after a year. We have New Year's Eve every year, the same.
So then it is apparent movement, because actually the star never moved anywhere. It's back in the same place.
The Earth is moving around the sun, and that creates this motion. It's just like if you're driving and you look at a tree as you're driving, you'll see the background move against that tree. Same thing, same thing. Anyway, can we move on? I've got a bunch of these experiments. This is an experiment that is real, and it proves the Earth moves around the sun.
It's called apparent motion for a reason. It's not called motion, it's called apparent motion, because it is an assumption.
It's
not fact. It's an assumption.
Mark, have we actually measured this?
Yes.
Yeah, we have photographs of this, right?
Closest stars appear. The reason the word appeared is because it's not really moving. It appears to move because we're moving back and forth.
It's the Earth that's doing the moving.
Would you say it's an assumption?
They appear to move when they're not really moving.
So then what's
It's
moving?
us that's moving.
Oh, but how do you prove that? Because I just showed you where
We're-
We measured it.
We have pictures of this. Can we move on?
So Einstein was wrong? Is that what you're telling me? Einstein, when he said there was no experiment that can prove Earth is moving, he was wrong.
Einstein was talking about if you're in an elevator that's falling, how can you prove that?
Would you like me to quote it again and take you to it?
No, I wouldn't. But because
Okay.
Einstein was saying the theory of relativity, the laws of physics are the same in all reference frames.
Einstein said he cannot
Dave?
prove the Earth
Yes.
is moving.
A lot of his quotes had ellipses in them, ... He's
Yes.
left that out.
Oh, I love this
You've
book.
left that
I love
out,
this
and that's
book.
what Dave is referring
Look them all
to.
up, because I gave them to you. Look them all up and prove
No,
it.
no.
Don't say I quote mine. Don't say I cherry pick. Don't go all that bullshit, because I hate that shit too. That's why I gave you the quotes, gave you the page number. Go look it up and point it out to me, and then tell me.
But you're not using the complete quotes, that's what he's saying.
quoted Einstein as saying Earth does not move.
I didn't quote Einstein. I gave you what Stephen Hawking's quoted Einstein as saying.
Well,
I guess he's
but
wrong,
you
too.
quoted Hawking
If you
saying
were on a
Einstein.
train
Hawking,
and the train next to you is moving, it makes you feel weird.
For a second.
Because it's hard to measure. Is it me moving or is it that other train moving? That's what he's talking about. Things are relative.
I just quoted 15 scientists telling you that you cannot prove the Earth moves. But yet here you are telling
Well, here's a well-established, accepted experiment that proves the Earth